So this is the title of the talk, but I'm going to call it Tools Matter. Simplify it a little bit. So I am Simon Woodside. I am the co-founder of MedStack. And really briefly, what we're doing is it's a hosting platform for medical apps. So if somebody's making an app that will interact with the healthcare system, they have to deal with a lot of privacy security issues. They have to deal with compliance. So in the US, it's called HIPAA. In Ontario, it's called PHIPAA. Every province has its own acronym. We're talking like hundreds of pages of legal stuff about encryption and firewalls and privacy officers and paperwork and all kinds of things. Lovely. Our goal is to make it easier, or much easier, in fact, for a app developer to be able to handle all that and focus on making their app great healthcare app that will help people with their medical problems. And then finally, of the sort of third pillar of our design is developer flexibility. So starting out about 3 years ago, all right, we set out to build a hosting environment, a platform that has these three features. And I'm going to talk about the road traveled along in terms of how we achieve that through the use of tools. So to start off with, this is like my Simon sort of cloud layers kind of picture. The picture is supposed to be cloud layers of clouds. You can't really see it, but the layers of the cloud. So infrastructure is the bottom layer, right? So when we're talking about like we Simon, MedStack, and we talk about infrastructure, we mean AWS, Azure, Google, okay, IBM, whatever they've decided to call it today, maybe a few other companies, but we're talking about those people as infrastructure providers. Then we say the second level is being like the sort of operating system level, services level. So Linux is the one we use for virtually everything. We're also talking about running things that are running on Linux, so Nginx or Apache or Postgres, MySQL, whatever it is. Finally, the top layer, this is where our customers are, right? So this is the app that you are writing and how you deploy that app. So the code, PHP, Python, Ruby, JS, whatever, and how you deploy that. So that's just a little bit of a map. We made the conscious decision, all right, that we were going to accept anything at the bottom and anything at the top, which may sound a little crazy because we're going to our customers and saying, hey, you want to run a medical app? Well, we're going to make everything secure, but you can run it on any infrastructure provider, any of the major ones, and you can use any language you want, and you can deploy it using anything from like git push to deploy, like Heroku, or you can just log in and like type stuff in manually. You can do whatever you want. And that was the challenge for us. So how are we going to make that happen? So how are we going to tool that? So I always think it's a little funny that programmers often will just settle on a few tools, a few languages or whatever. If you were ever to go to a chef and say, oh, you can only use one knife, they'd go crazy, right? Like, you're not going to use a boning knife to cut some bread, right? So I think it's very important to look at the world and say, hey, you know what? People who make things are often using many, many tools, even hundreds potentially of tools. They could have like a chisel and they've got like 20 different chisels, right? So keeping that in mind, I decided I was going to start by doing everything manual. Okay, so the first few customers we did, the first customer I did was all manual because I didn't even know what was going to be involved necessarily. I mean, I've done lots of Linux administration process, but I didn't know exactly what would be involved. So I did it by hand, and then we moved up this lovely sort of upwards curve here of tooling. So took the stuff I'd done manually, and I kind of written it down in a doc, and then I was like, all right, I'm going to make bash scripts. Great. Bash scripts are a real pain in the ass. If you run them again, they break everything. So then I went to Ansible. And Ansible is idempotent, which means, fancy word meaning you can run an Ansible script 20 times, and it will only change the things that are actually different. It won't change things that are you've already done. And then we added Terraform to that, and now we're adding some additional sort of stuff we're writing. But this is completely simplified view of what actually happened, right? Because, of course, every stage in that progression involved lots of pain and discussions and arguments and so on. because there's actually so many tools. So, I mean, even you could say Linux. Why did I use Linux? Or what version of Linux am I using? I didn't even include this, right? But like, why Debian? Use Debian. Why didn't we use Ubuntu? Why didn't we use Red Hat? Why didn't we use OpenBSD? FreeBSD, for example, it's more secure, right? Or OpenBSD, which I think maybe some people say is even more secure than that, and so on. Why didn't we use CoreOS? Why didn't we do everything with Docker? And then we could use Docky, which is like an open source Heroku clone. Or we could use, instead of Ansible, anybody here use Ansible? Yes? Oh, actually, quite a few people. Cool. All right, well, I'm getting such a great response. Anybody here use Chef? Okay, Les, that's cool. All right, Puppet? Salt? Oh, you use everything, basically? Yeah, okay. Oh, wow, I'm really pleased to see that more people are using Ansible. So I made the right choice. So, my philosophy was, all right, I'm going to just start any tooling search by trying to find out what all the tools are that are kind of in the field I'm looking at, right? And then try to form my own opinion, because there's definitely like a bandwagon effect online, right? Like if you go online and you look up DevOps, it's like all about Docker. At least it was last year, anyway, when I was doing my research. My last round of heavy-duty research. It's all Docker, right? Yes, is it all about Docker? Yeah. It's like 95% Docker. But the reality is like 5% of people, 10% of people are using Docker, and the other 90% are not, like, using something else. They might be using other containers, or they just do something completely different. So just because there's like a lot of articles being written about something doesn't mean it's good. So as you do your breadth-first search and start looking at all the options, you also have to form your own opinion. So my opinion about Ansible was, oh, I like this because it's Bash, but better, right? That to me is what it is. It's like everything in Ansible looks like Bash because it was designed that way, but it's just like way better than just writing Bash scripts because also it was designed that way. So I like that. It made a lot of sense to me. Also, it's more modern. It had many attributes. But actually, there was less. A year ago, there was a lot less written about Ansible than there was about Chef or Puppet. So it wasn't the obvious front runner. Another thing is go to events, right? Go to something like DevTio, find out what people think. Don't just read stuff online, because you don't always know where that kind of opinion's coming from. Could be somebody who's really good at writing, doesn't actually code. It's hard to say. Finally, going to events allows you to discuss it with experts. So like I would call up people I knew who were doing big cloud projects. I'd be like, hey, what do you think about this, that, and the other thing? They tell me, right? Actually, I do want to mention one more thing on this one. Going to conferences even, it can be obviously a bit pricey. But we went to Ansible Fest, which is like, 1,000 people all using Ansible. It was pretty cool. For a couple of days in San Francisco. And it actually really validated one architectural decision we'd made that didn't seem completely obvious, because I want to know, do you use Terraform? How do you divide your use of Ansible? Or what do you use Terraform as opposed to all those other things?
Terraform, you use it just to build the infrastructure. Ansible to configure it.
Perfect, okay. Yeah, so he said is using Terraform to build the infrastructure stuff, and then Ansible to configure things, which is exactly what we settled on. But again, it's not obvious in the literature online that that's what you should do. So Ansible has all kinds of modules to configure infrastructure. And so it's not necessarily completely obvious that you would want to say, forget about that, I'm not going to use that, I'm going to use Terraform. But the reality is, and we had this validated really nicely for us when we went to Ansible Fest, was that was actually a great architectural decision we made. So again, don't have to do what everybody else does. Check it out, think about it. So I'm a little on the older side. And when I was in school, UNIX was a big deal, right? Still is, cool. Yeah. That's great. So this is the UNIX philosophy on the left here from Ken Thompson and Dennis Ritchie. Summarized as write programs that do one thing and do it well, write programs that work together and use text-based interfaces. This is 40 years old. That was written 40 years ago, all right? So, hey, now we're writing REST APIs to use JSON. That's a text interface. Things have kind of not gone that far, right? So maybe there's something to be said about what these people were saying. So the idea in general is choose your tools, but use them in a nice modularized way. So again, use Ansible for what it's really good at. Use Terraform for what it's really good at. Terraform's really good at setting up infrastructure stuff. Ansible's really good at configuring Linux VMs. Use them for their thing, and set up simple ways for them to communicate with each other. And that leads on nicely to security, because one of the biggest drivers of security flaws is bugs in your code, basically, right? So this is from this picture is it's from a book I read as a kid. Does anybody recognize it? I don't suppose anybody will. So David Macaulay wrote this book for kids called Castle, and he also wrote How Things Work, which I think more people have heard of. And it's all about these castles that were built in Wales by the English 500 years ago. And at that particular moment in time, the English had not really conquered Wales properly. And so they were trying to establish these sort of beachheads in Wales, but the Welsh were coming and kicking their asses, right? So but the English had a lot of money, and they had advanced the art of castle building to pretty much its peak. Like they had round towers. That was a big innovation. It's harder to break a round tower. So what did they do? All right, they had insecure areas and they had secure areas. This is the town, and these houses were not built in a secure manner. They were kind of like Windows desktop systems. So they had to build a wall around it. So they had the perimeter security, right? So they have this is your parameter security. This is like your SIM system, like your security incident and event management system. Like you're just going to assume that anything that gets through the perimeter is going to break. Is going to like be like a knife through butter. It's like going to install malware on everything. So everything's about the perimeter. And if something gets through the perimeter, you're toast. And we were at one of my staff were at Sector, which is a cool security conference 2 weeks ago, I think. There's like 10,000 people there. It's great. If you haven't heard of it, check it out next year. But then the castle's different, right? So the castle is built secure by design. So you start from the beginning saying we're going to build something secure. So, sorry, I'm like moving off the video here, but that's just too bad. So what they're doing here is they've got many layers, all right? So first of all, it has a separate wall, which is actually higher than the town wall, and it has certain access ports, right? It has the SSH port and the HTTPS port running on Nginx. Great. So once somebody gets through that, then they're in I think they call this the outer bailey. I was a castle nerd when I was a kid. This is the outer bailey, right? You're still not in though, right? Like, so you can get through the first layer and you're still, the people inside the castle are still secure. Then they have to go to a second layer, which is higher. So this is maybe where maybe inside here, somewhere up here, you've got your healthcare data, right? So then they have to get through the second layer, so another castle, and then even if they're in there, these towers, each individual tower is actually not accessible from the ground level. You actually have to climb up the inner wall, and then you kind of can go in here, and then you can go back down again if you want to move the box. So they built this. And they built it on this lovely hill to bedrock. You could be like, this is your AWS security, right? The rock you built it on. So this philosophy is called defense in depth. And defense in depth is awesome because if one layer breaks, you still got another layer and maybe another layer after that. And I think that's great. I think for us, we want to have like 3 layers on everything reporting. And so I'll give you an example. This is our backup. This is like a super simplistic version of our backup system. So we take that data. It's a copy of the entire database. So that's like gold because you could sell a person's health record for like hundreds of dollars because you can loan money based on it and you can defraud people. It's wonderful stuff. So that sits, and that'd be like that could be like thousands or tens of thousands of people's records in that backup. So we put that, we GPG encrypt that. So we're not just going to use S3's, server-side encryption. We're going to use GPG encryption. Then we're going to put it maybe in an S3 bucket, something like that. And then we'll have lifecycle policies. So what if somebody were to overwrite the data? We would lose it, right? So then we're just going to say, all right, instead we'll have versioning, for example. So anything that's tries to overwrite, we'll just create a new version. The old version will still be there. And then we'll have data access restrictions in terms of like authentication. And then we'll have more, okay, so there's more layers actually, but just an example. And like I said, security always breaks. We're always mitigating security problems, but we have been very successful in this particular system even where we have occasionally seen, oh my God, there's a problem with one layer, and we didn't have a big problem because we had other layers that were keeping us safe. So I won't tell you, I won't give details, but pragmatically speaking, this has actually been a practical system for us. And I'll sort of wind up with just some code because everybody likes to see code. Yeah, you can probably read that. So this is Terraform. So Terraform uses a JSON-based domain-specific language. You can write modules. So this is all sort of calling into a module that we've created, and it's just creating one server in this case. But if you wanted to create two, you just add an extra block, server block, and so on and so forth. So you can kind of set up a pretty complicated system with like a couple pages of Terraform code. And then Terraform lets you run a plan phase, so it will tell you what it would do if you were to run it. It will run an apply phase where it will actually go ahead and make changes. If you then were to go, so if I were to run this and then I were to go and change the VM size, for example, that's an Azure size. We use Azure a lot for Linux VMs. So I were to change that to like a D3 V2, it would then, and I ran plan, it would say, all right, I'm going to destroy the D2 V2 VM and I'll replace it with a D3 V2 or whatever. So it's pretty intelligent about how it tries to do the minimum amount of change necessary to fulfill your code changes. And then here we have some Ansible. Again, it's a DSL. It's, in this case, in YAML, which is even nicer than JSON. Yeah, so really, at the top, we're basically kind of saying, these are a bunch of modules we've written, and they're going to be used in configuring the server. So we're going to have an encrypted data drive. We're going to have the deployment system. We're going to have a firewall. We're going to have Let's Encrypt certificates. We're going to have an Nginx installation, Postgres, some backups, and then we'll install JK8 so somebody can run Java code. And one of the things I'm really proud of is all of our library code. So we're like 2 years in, let's say, ready code. There's only 5,000 lines. And I'm bragging, right? Like to me, that's awesome. Only 5,000 lines of code, roughly like 6,000, whatever. That's it, and it's great because I really am one of the people who believes in this. Like every line of code probably has a bug in it. And so the less code you have, the less bugs you have, which means your code is more secure, if you care about security. And of course, you can't achieve that without great tools. You have to have great tools. So to summarize, start small, start manually, build up from there. As you need tools, do the breadth first search. Try to keep your architecture modular. It allows you to use tools that are specific to the job and combine them together. Build secure from the start if you need security, which you all do, because you're all going to get hacked, as we have, I'm sure. And write as little code as you can and be cool. And that's my email. I don't really use Twitter, so if you're interested in chatting, reach out. And that's it. I can take questions now. Thanks. Does anybody have a question? Yeah.
Yeah, question for you about your customers. So are they ever in a position where outside of the code level, can they make changes that would compromise the security that you keep them?
That's a great question. Where's Nick?
That's where I'm up.
So when we started out, yes. Now, no. Because we kind of started, this is very much of a lean startup, right? So we're like, let's just try things and see what happens. And what we discovered was if we allowed our customers to have root sudo access on a VM, no matter how well-intentioned they were or what they said, pretty much inevitably somebody was going to go and break something. And we wouldn't even know about it probably for a while because we weren't necessarily tracking every single little thing. So at this point, so in general, our philosophy is like, don't allow the customer to shoot themselves in the foot. That said, it's really hard because if you have a customer who's running PHP, like there's so many ways they can break their security of their app that way. They might not be breaking our security, but we can't prevent them from like having command injection or letting somebody upload a file and then run it as an executable or something like that, right? So we try. We do a lot, but no system's perfect.
Is there
stack limited only to public cloud, or do you touch like on-prem solutions or private clouds that maybe larger companies have?
Yeah, so we're public cloud only. It's kind of interesting in our industry. The hospital are all running almost exclusively on-premises systems, but our focus is on helping the healthcare system use apps. And as it turns out, the hospitals don't want to be running those apps on their on-premises systems. They don't like that because that's like a security risk, right? So they would much rather have those apps running outside, like on our system. And then we have interoperability solutions like FHIR, FHIR, and things like that to allow the intercommunication.
As you hire developers, as someone who's Microsoft change for them, if anyone tried it, it's like, we should do it like this. How are you?
Yeah, for sure, and that's great. Like when we can hire somebody who can bring in knowledge like that, it's fantastic. So I would say so we're 7 people, right? So I've hired 3 tech people so far. We'll be hiring again like in a few months, so keep an eye out for that. And I would say every single one of those people has brought in new ideas, which have been key to our current trajectory. Yeah.
As you've been going along the path to where you are now, and you're kind of looking back at the decisions that you've made, has there been like one stand-up decision where you're like, oh man, we wish we would have like went this direction versus this?
Yeah, for sure. So I should have brought this up in my talk because it's like a perfect example of what not to do. So we built a system which was supposed to be monitoring our systems, and it was built in a very monolithic Rails app, and it did not work out at all. So it was too inflexible. It was, as I said, it was monolithic. Everything was all in one big ass Rails app. It didn't talk to outside systems really using APIs very much. We didn't really evaluate whether or not Rails was even an appropriate system for monitoring, which it isn't really. As like Active Record is just not a good database, or like an ORM for doing huge amounts of logs, things like that. So yeah, does that count as an answer to your question? Any other questions? Yes.
Kind of a two-part question. What would you say is the easiest piece of security you could install if you were just getting started with security, or if you were going to stand up a simple web app? And what would be the most important if they're not the same?
I think backups. I mean, this is brain dead, right? But backups are so important. Yeah, okay. So it's just like so easy to either not be backing stuff up or to be doing it maybe not so well. What was the company that was doing it?
Or doing it wrong.
Doing it
so
wrong,
it doesn't
yeah.
work.
Like what if you're doing increment? Okay, so backups and then testing a full restore, right? So there was this kind of, who was the company? Git something or other? GitLab, right? And so they were doing incremental backups, and Nick,
I don't know the details. They were doing something and then they got other
their backups were like corrupted or whatever. Like they'd been doing incremental backups, and like the first one had been corrupted, so they couldn't like put them together, and they're toast, right? So I remember feeling when I designed our backup protocol, like we're gonna do like a full snapshot every hour. I think it seemed a little extreme, maybe, but it doesn't anymore. Yeah. Cool.
So is that easiest or most important, or both?
Both. Well, I don't know. It's easiest, but that's definitely the most important. Yeah.
Okay.
Firewalls, those are pretty easy. The fact is, you can always say stuff like, "Oh, SSL," right? Like that's important, right? But you also have to make sure you're not doing anything that is not SSL. Like it's so easy. For example, if you use Docker, Docker has root on your system, and it can open ports in your firewall. So it just so happens we were running UFW, which is the micro firewall, I think, simple firewall. No, sorry, it's not micro firewall. It's uncomplicated. Thank you, uncomplicated firewall, and that's great. But it turns out Docker can override UFW without UFW even knowing that happened. So you could think all of your ports are encrypted, and they're not. Yeah. Scary stuff. Why would they do that? Anybody from Docker here? All right. Any other questions? All right, well, thank you very much.
Thank you.